This video is about index numbers. Index numbers, they measure the relative change in the level of a variable from time to time or from place to place. The methods are simple aggregate method, where you just add the prices of current year for price index number and divide by the sum of the prices of the base year and multiply the ratio by 100. And the next method is to compute the average of price relatives. The price relatives are computed as P1 by P0 into 100 for each item. And then you can consider the arithmetic mean of price relatives as the index number, or the geometric mean of price relatives as the index number. And the weighted index numbers, where for price index number, quantity are used as weights, and for quantity index number, price will be used as weights. And by last year's method, the base year quantities are used as weights. In past's method, current year quantity is used as weight. And Marshall-Edgeworth method considers the average of base year and current year quantities as weights. And Darvish-Bowley's method is simply the arithmetic mean of last year's index number and past's index number. Fisher's index number is the geometric mean of last year's and past's indices. And Kelly's index number, it doesn't use the base year quantity or current year quantity. It uses the quantity of some standard year as the weight. Now, if price, generally the price of the commodity increases, right? If that is the case, the last year's index number has an upward bias, because when price increases, quantity consumption decreases, and the decreased quantity is used as weight, due to which this index number has an upward bias. And for the same reason, past's index number has a downward bias. Right? Okay. Next, the test for index numbers. The unit test, with this test is satisfied by all index numbers except the simple aggregate method. This method says that the index number should be independent of the unit in which the data is expressed. The time reversal test, if you use the current year as the base year and base year as the current year, if you reverse it, the product will be equal to 1. This is time reversal test, and this is satisfied by Fisher's index number, Marshall-Edgeworth's index number, and simple geometric mean of price relatives. Only these three indices satisfy time reversal test. Factor reversal test, as the name implies, says the price index number computed by a particular method into the quantity index number computed by the same method should give you the value index number. Price into quantity should give you the value. So this test is satisfied by Fisher's index number only. Circular test is an extension to time reversal test. It considers 3 time periods. P01, P12 into P20 should be equal to 1, and this test is satisfied by simple geometric mean of price relatives and Kelly's index number. So only these two satisfy circular test. Only Fisher's index number satisfies factor reversal test, and the Fisher's, Marshall-Edgeworth and simple geometric mean of price relatives satisfy time reversal test. And unit test is satisfied by all indices except those which are computed using simple aggregate method. Okay. The relationship we shall discuss in the next video. We shall now have some questions based on the things which we discussed so far. The measure which is suitable for constructing index numbers are arithmetic mean, or geometric mean, or harmonic mean, or median. Geometric mean is generally used to find the average of rates and ratios. It is highly suitable to construct index numbers. Index number is the sum of price relatives, average of price relatives, product of price relatives, none of the above. It is the average of price relatives. Okay, which is an extension of time reversal test. Factor reversal test, or unit test, or circular test, or sample test. Circular test is an extension to time reversal test. Factor reversal test is satisfied by which index number? Laspier's or Parkes or Fisher's or Darvish. Only Fisher's index number satisfies factor reversal test. Laspier's index number does not satisfy time reversal test, factor reversal test, circular test, all of the above. Laspier index numbers generally they do not satisfy any of the tests. All of the above is the correct alternative. The test which is not satisfied by Fisher's index number is, Fisher's index number is an ideal index number. It satisfies time reversal test. It satisfies factor reversal test and also unit test, but it fails to satisfy circular test. Which of the following satisfies circular test? Geometric mean of price relatives, arithmetic mean of price relatives, harmonic mean of price relatives, none of the above. Geometric mean of price relatives is satisfies circular test. Which of the following does not satisfy unit test? We have seen that all indices except those which are computed using simple aggregate method satisfy unit test. So, which does not satisfy unit test is this one, simple aggregate index. The arithmetic mean of Laspier's and Parkes index number is, arithmetic mean of Laspier's and Parkes is Darvish-Bowley's index number. The geometric mean of Laspier's and Parkes index number is Fisher's index number.